Hello students, in our last class we discussed about the metallic and non-metallic character and we have seen the grid. That means how it will vary down a group and across the grid. Now our today's topic is ionization energy, or we call ionization potential. Okay, so the definition tells us the energy that is required to remove an electron from the outermost cell of a neutral gaseous atom so that it can be converted into a positively charged gaseous ion is called ionization potential or ionization energy. So basically ionization energy is the amount of energy required to remove one electron from its outermost neutral gaseous atom to convert into a positively charged nucleus. Say for example M, we have taken a metal M which is in the gaseous form. So the amount of energy that is required to remove one electron from the outermost cell. So if it removes one electron, it becomes a positive ion, that is cation. So whatever amount of energy is required, that we called ionization energy. And ionization energy is measured in electron volts per atom, and the SI unit is kilojoule per mole. Okay, now it's trained, that means how it will differ across a period and down a group. So across a period, that means when you move from left to right in the period, the ionization energy increases. The reason is that as we move from left to right, the atomic size decreases, and we know that why it decreases, because the electron has got more force of attraction towards the nucleus. Because of that the last element from left to right, they will have a very high ionization energy. That means they required huge amount of energy to remove the electron. And basically the inert or noble gases, their ionization energy is very high because of its stable electronic configuration. Now when you move down a group, as we know, there is increase in the atomic number as or the number of cells also increases. Now as the number of cells or orbit increases, the size also increases. Now when the size increases, what happens? The last electron will have least attraction towards the nucleus. That means if you supply less amount of energy also, we can easily remove it. Therefore we can say that ionization energy decreases with the increase in the atomic size down a group. Okay, so across a period increases and down a group decreases. Next we have got next periodic properties, electron affinity, or we also call it as electron gain enthalpy. So we'll know its definition. It is just the opposite for ionization energy or ionization potential. So electron affinity is the amount of energy released. Now it is not a energy required, but it is the energy released when you convert a neutral gaseous isolated atom into a negatively charged gaseous ion by the addition of electron. It's called electron affinity. Say for example you have taken an element X. Okay, say for example you can take a halogen, either chlorine, bromine. Okay, so this this element, when you add one electron, whatever amount of energy that is released, that we call electron affinity. So when you add an electron to this gaseous element, it will convert into a negative charge, that is an ion. So this energy we called electron affinity. So ionization energy is the amount of energy required to remove an electron from the outermost gaseous atom, whereas electron affinity is the amount of energy released when you add one electron to the outermost orbit to convert into a negative ion, and its unit is electron volt per atom.